Отже, наш наступний доповідач Armin Nesiren з компанії CyberTech, він розповість нам про PostgreSQL в Kubernetes. Будь ласка, Armin, оплески.
Hello, thank you for coming in this large number. I'm going to talk about how do we run and how we could run Postgres inside of Kubernetes. So I work for CyberTech. CyberTech is a database company. We work a lot of things with database. We are an international team of developers specialized in data services. CyberTech is a worldwide company. We are spread in Europe, something in South America, and so on. And we have some nice clients with nice logos, with a lot of different industries. And a little bit about myself. So I'm Armin Nesiren, as Paolo said. I'm database engineer, as Paolo stated in his documents. And from 1st January of this year, I'm in CyberTech. A little bit more about me. So I'm born in Sarajevo, Bosnia, most known by war and Olympic Games. I started as a software developer 15 years ago. And about 10 years, I'm dealing with Postgres in different situations. Started with replications, with trigger-based replications, Slonis, and then stuff like that, and then moved to streaming replication and managed a few clusters with HA and so on. And lately, I'm dealing with stuff that is called DevOps. And recently, when Kubernetes showed up, I started dealing with that. So I mixed kind of experiences with Postgres inside HA for Postgres with Kubernetes stuff. And I'm going to talk about that today. So why would we run Postgres inside of Kubernetes? So we live in the world where service-oriented architecture is a common thing. We build software as a service, and we actually move everything to be as a service, and that helps us with a lot of things. So there's a couple of ways to do the same thing with Postgres. And why do we choose Kubernetes for doing that? It's basically future of Kubernetes looks bright. It's major companies are behind it. That large communities dealing with it. It's free. You can test it home. You can test it easily, in different ways. And with combining all of that, Postgres could be available quickly for everyone. So if you have one team and want to provide database for them, just quickly make it inside of Kubernetes with HA, with replication, with failover, and stuff like that. So Postgres running in Kubernetes could make life a lot easier for a lot of things. What I will talk about in this session, Postgres and Kubernetes, I will mention some Kubernetes basics and the Kubernetes large story. I will not go into details. Some pre-knowledge of that will be helpful there. So I'll just cover the basic stuff. I'll talk about how Kubernetes could handle storage for us with running Kubernetes in it, Postgres in it. And I will say about how we could deploy Postgres simple way without any HA, without any replications, and how we could do it as a whole package to provide complete service with high availability load balancing and everything. So yeah, I didn't mention. Yeah, I'm okay with questions during the talk. Just ask. And also, I'm not native speaker, so. But I'm sure we will understand each other. So, what's the deal here? We are dealing with containers here. So we try to put Postgres in containers. Why containers? We love them because they cost less. When we run something in container, we kind of do it isolated. We don't need whole server for that. So that will cost us less. They are lightweight. If we make them lightweight, they kind of stand alone. They can be moved from one environment to another, and they run the same way as another. And they are helpful for a lot of things. Now, inside of Kubernetes, so Kubernetes is basically managing those containers. Container by itself have we are not able to actually do a lot of things with containers by itself, and Kubernetes helps us there. It helps us to avoid downtimes by doing by managing the auto deployment and like starting the new container, and when the container is healthy, it brings down the old container automatically, so we don't need to deal with all that procedures, and also do the load balancing. We can run a lot of containers behind and make one load balancing service pointing to them, and then the Kubernetes will do the job for us. Then we have we could do storage orchestration with Kubernetes also. I'll talk about that a little bit later in a few slides. As I mentioned, rollouts and rollbacks, we can quickly deploy stuff, make them inside of Kubernetes, and then if something goes wrong, we can quickly revert back to the previous state. Also self-healing. If Kubernetes find out that one container is not running well, it will, if we make it do so, it will just kill that pod or container and start it again. And also we have the management for secret and for configuration. So we are for sensitive information, we are able to do that nicely in Kubernetes. So basically, containers managed with Kubernetes are whole package. And now Kubernetes is, as we know, can be run on bare metals, or there are providers for Kubernetes. Now, in this talk, I will cover the bare metal situation, which would also cover the Postgres and Kubernetes in one of the providers. So it's just a little bit more challenge. There are some more challenges when we run it on bare metals for bit storage and service discovery and stuff like that. But let's say we have some spare service. We want to build a Kubernetes cluster, and how we could do it and how we could run Postgres inside of it. So with providers, definitely there are less stress. Someone else is taking care of Kubernetes that is healthy and alive, and that all this hardware is under control of provider. In case of bare metal, we definitely need some knowledge with configuring servers and installing all the stuff. All those Ansible scripts that are out there are working well and helps us a lot. So if we do it manually, then it's pretty hard. With automatization, that is a lot easier. And if we want at least some kind of H availability the proper way, we need to go at least with 3 to 5 servers, and then we can scale quickly, because it is designed to scale. We can add servers pretty easily. We need to think about storage options, because each of the Kubernetes node needs to have access to the same storage. And Kubernetes itself have its own way to expose a service. We need to make a route to the each of the masters of Kubernetes. In case of the one master that is running API failed, we need to route the traffic to the another server and take care of that. And that's not the case with the bare metal with the provider configuration. So in this picture, there is a simple Kubernetes architecture with everything that I've described in previous slides. So this is how it looks like, the basic simple version of it. We have some servers that are acting as a nodes, and beside them, we have also servers that are acting as a node and as a master. On the master, we have some pods or some containers that are doing some roles like API, and they are in charge of scheduling where will start, what will start where, and basically on each node we could just install one operating system. We can install like Docker servers. I would consider that we are using Docker here. We can use some other containers, not just Docker, right? And there is one little service named Kubelet that is communicating with Kubernetes API and taking care of that everything is running properly on each of the nodes. And then on the master servers, there's the same thing as for node, except there's a few more services taking care for API scheduling and etcd. Now, each of the nodes of Kubernetes needs to have access to one storage, to the same storage. I mean, when something is running on node 1, for example, and for any reason the process is shut down there, and the same process, same pod with the same task is started on another node, that physical server needs to have access to the same storage. For our case, when we are running the database, and database need access to the data. And of course, each of the node needs to have access to image registry, that is Docker image registry, to be able to pull those images and to start them inside. And Kubernetes, how does Kubernetes make those stuff inside on Kubernetes level? There are some resources inside of Kubernetes that are like that we are dealing with, and that are creating stuff behind. So there is concept of pods that is like lowest level. Inside of Kubernetes, there are pods running, and pod is representing one or more containers that are binded together, or that they have the same task, and they have their own network, and they are always running on the same node. So if we have 2 or 3 containers inside of one pod, if we want to move them or start them on some other node, they will always be in the same node. As I said, they have shared storage and networking, and they are always co-located or co-scheduled. Now, there are namespaces. There are basically virtual clusters inside of Kubernetes. So when we put something in one namespace, that is like isolated from other namespaces. And also we have secrets. So each pod, for example, can access some secret. We store secrets inside of Kubernetes, and then those sensitive informations are not visible, except the pod can mount that secret and use it. And then we have some other resources, because Kubernetes call all these things resources, like deployments, that are basically in charge of making pod in desired state. So if we create one deployment and we said we want image of Postgres to be run, and the number of replica is, let's say, 3, the deployment will create 3 pods and run them in probably on different nodes. And on top of that, there are services with different types. So if you want to access that pod, pod is like not in permanent state. For example, it can run in one node, and when we restart it or redeploy it, it would be run on the different node. And we need one point of access to that pod. And for that, we are using services that are created on top. And the service is taking care to find that pod each time we want to access it. The different kind of services exist in Kubernetes. I will not go into details. We probably want to use load balancer service that is balancing query. For example, if we have Postgres master and the replica and want to access to that Postgres, the load balancer service will take care of sending requests to one or another pod. Now, how do we talk to Kubernetes? How do we tell Kubernetes, let's create something? Or the common way for playing around is kubectl. It's the common representation of Kubernetes API. It translates every command into the Kubernetes API call and talk to Kubernetes API and give us some output. So we can basically get everything and send that everything to Kubernetes via kubectl, or we could prepare the whole bunch of information in one YAML file and then send that to Kubernetes via kubectl. Or we could talk to the Kubernetes API directly via client library, and that is interesting if we want to make stuff automatically, work automatically. If we have some code and we want to talk to Kubernetes based on some logic, we can include client library of Kubernetes and then do the same thing as with kubectl. There are client libraries for major languages. Now, this is the example of one YAML file. So this is the simple version of deploying the Nginx inside of Kubernetes. So we would just create this file, stated that this is deployment resource. We would give it some name, specify the number of replicas, give some labels to them, and we would make a specification of container. What container should Kubernetes use? In this case, this is image hello world with the latest tag, and sending this YAML file to kubectl would create 3 pods running on 3 different nodes, probably, if we have three servers. And each node physically would pull the image from the image registry, start the node, fire up the node, and we would have the service there. Now, how do we do the same with the Postgres? We would just basically change the image name, use the Postgres official Docker image, pass the parameters, and that will be it. But if we want to do it properly, there will be a lot of configuration for Postgres. If you want to make a custom PostgreSQL conf configuration, if you want to do it like, if you want to change something, it will be hard to manage that kind of container to keep the data or to avoid downtime, and this will be pretty hard to configure and make that live. And of course, there is no easy manipulation with clusters to update or delete something. It's just not doable for any kind of production environment. And of course, if we want to run multiple instances of Postgres in this kind of setup, it would be, and if you want to add for each of them one role, Postgres role, it would be hard to do it each time, or to make some scripts to create after each configuration and initialization of database to create one role of our desire, not to mention to add one colleague after that. So what if there is some small Docker image already prepared for this that have a lot of versions of Postgres inside? So if we want to run on an old version for someone or to try the new one, what if there is a lot of extensions already prepared and additional tools that we might require? And all that with environment-based configurations. So passing the configuration is based on some variables that we pass to that configuration. That would be awesome, right? And if you want to add some layer on top of it with the HA, that automatic failover solution with streaming replication and to keep cluster in desired state. So that's one layer that would keep those Postgres node always in up state, and it would take care if something goes down. Then we would use Patroni, right? But yeah, this would actually help us with a lot of things that we are not able to do with just simple Postgres image, with new cluster deployment, scaling, and configuration management. So the image actually that have everything that I mentioned is a Spilo image, right? That is from Zalando. I don't know how many of you heard about the company. There's one Docker image that combine all those stuff together and help us run Postgres nicely in Kubernetes. So how does that look like inside of Kubernetes? It's shown on this picture. Basically, on two nodes there are two pods. So the pod demo 0 and the demo 1 are actually running on different physical servers, and there is Kubernetes service created on top of that to access the pod 1, and additional servers that is always pointing to the replica version. There is secret that is created inside of Kubernetes that each pod have access to, and both of those pods have access to persistent volume that is accessible for each of the nodes of Kubernetes cluster. Now that is the tricky part. What happens if, for example, pod demo 0 for any reason stops responding, and it needs to be rescheduled, and it is started on another node? In that case, that node, that Kubernetes node, so physical server, needs to access the same storage that the previous node had access to. And how we could solve that problem? The answer is software distributed storage. And with software distributed storage also running in Kubernetes, we achieve exactly that. So with the Ceph, Ceph is under Red Hat, I think now. That is tool for software distributed storage. We could achieve that we have access to the same storage from each node, and we could run everything in Kubernetes. The requirement is that we, on the physical server, we have access to the block devices that are the members of Ceph storage. And with the Rook operator that is running inside of Kubernetes, we are able to configure software distributed storage and to achieve our goal. This is completely different subject, so I will not go into that, but it is pretty easy to make the test case and to test it on Minikube. This is Ceph plus Rook architecture for running inside of Kubernetes. Of course, there are other options. You just basically need to make sure that each Kubernetes node have access to the same storage any way you want it. This is just one way to do it. And now some of you might ask, why not using Helm? So the Helm is basically would take care of a lot of things that I mentioned before, but there are some downsides of using Helm, and that is, after the Helm would create the predefined cluster from template, it would not be able to do some logic afterwards. So if we let's say create 100 of Postgres clusters, and we want to add one role for our new colleague, that logic would not be possible in that case to implement, or it would be a lot harder. And that's why would be, and then if we look at the typical Postgres lifecycle of one Postgres service, right? It is like we create or update cluster, we deploy it, we maybe synchronize it, remove users, add users, add some default databases, remove them, and then we delete it. And with this having in mind, the one cool solution for having everything that's built in together comes to the as an answer. So that is the Kubernetes operator. The Kubernetes operators are basically the pods that are extending Kubernetes API and creating a new resources. So as we saw before, Kubernetes have its own resources, pods, deployment, secrets, services, and so on. And with operator, we are able to extend the API, create our own resource. And in this case, that would be Postgres resource. So all of a sudden, we would have one Postgres inside of Kubernetes, and we could manipulate the Postgres with Kubernetes operator. Like add one Postgres or remove one Postgres, and the operator would take care of everything behind. There are few solutions for Kubernetes operators. I will show about Zalando's operator. They are crunchy data operator, and recently some more of them. But the mechanism behind it is the same. They have some features better than the others. It's up to you to choose which one you would like to use. They help us, exactly as I said, with deployments, with cluster upgrade, and user management. So all of those requirements that we needed are encapsulated into this functionality. So against the Zalando operator combined with Spilo image, it defines custom-defined resource Postgres, so a new resource inside of Kubernetes. It constantly watches instances and keeps them in the state we are defined. It creates the update and delete stuff. It also creates database objects, roles, and password based on the configuration we gave him. For example, we create one Postgres instance with one configuration set, and if we add one role, the operator will take care to create the role inside of Postgres. It allows us to scale on the lowest level, so to add memory, CPU, volumes, and so on, and of course Postgres configuration. So we basically instruct Postgres operator about changing PostgreSQL conf, and the operator will take care of applying that configuration. And if in a case that Postgres needs to be restarted, there is a patroni behind it that knows how to first change the role of master service, change configuration there, and then move back to the new server with the new configurations, so you would not experience downtime, for example. And of course, take care of auto repair, so it constantly watches if we create one operator, one PostgreSQL resources, for example, with 3 replicas, and one of the replicas failed fails for any reason, the operator will know how to create a new one and keep the cluster with the same amount of replicas. So how does the manifest for Postgres operator looks like? As we saw before, I don't know if this is visible with this black background. I forgot to change this background. So basically, if you can remember how the deployment manifest was look like, this pretty much the same, except it is small number of arguments, and we are getting a lot of behind because all this logic is inside of operator. We are defining the resource name. In this case, that is Postgres. We give a name to him, and we set the operator how much of volume size we want. Now requirement for this, that inside of Kubernetes, for example, you have implemented Ceph plus RAC infrastructure. So in this case, Postgres Zalando operator would be able to allocate the memory that we gave him here automatically with dynamic allocation, and that is pretty helpful. And of course, the number of instances, some roles that we want to have in database, what version of Postgres we want. For current spill image, I think the supported is up to 11. I'm not sure if the 12 is supported yet, but it will be probably soon. And when we apply this manifest to Kubernetes API, in the background, there will be created one pod that is operator, and that operator will create instances of master and slave, and provide a service, and provide a secret, and make a configuration. This is basic configuration. It can be extended with custom PostgreSQL configuration and backup configuration, of course, and the resources for each pod in terms of CPU and memory and so on. This is just a basic test manifest. And how the stuff looks like at the end with all the stuff that we want. So the operator is actually creating not deployment, but stateful set, because we always need the same pod names. And the stateful set is controlling pods, spiller pods that are where our Postgres is running, of course with Patroni behind on top of it. That's all the task of the spiller image. Spiller image is using etcd of Kubernetes for taking care of HA. So in case of one Kubernetes node die, the others will know about it because they are looking at Kubernetes etcd. The operator pod will control secrets. So if we change the secret, if we instruct operator pod about changing a secret, the operator will automatically talk to that resource. It will create, if we instructed two services, one for accessing a master Postgres instance, and the other service for accessing the replica instance. And roles, of course, we saw on previous YAML configuration some roles there. If we whatever we add there, the operator pod will take care of creating that. And client application basically just connects to the service, and that's it. Now in bare metal configuration, this exposure of services is kind of trouble, because on the providers on Kubernetes that are managed by providers, when you create one load balancer service, you would get public API. Now, in order to help you with this, because in bare metal configuration, Kubernetes don't have the idea how to get you public API. You can help yourself with the Meta LLB code. That is basically Google's code for creating, for adding public IPs to load balanced services. And with configuring Meta LLB, you would add the block of IP addresses that are accessible to each of your master pods, and Meta LLB would create that public IP there. So everything is covered in terms of HA. So basically, with this picture in mind, we have a way of running our favorite database inside of Kubernetes. That's it. Thank you. Yeah.
From your experience, how many actual projects do you have when clients select such a deployment model? I mean, running
Please repeat the question.
So the question was, how, from my experience, how much actual projects are running inside of Kubernetes. So the best thing is shown by Zalando, the creator of Zalando Operator and Spilo Image. They are running more than 100 projects inside of Kubernetes this way, with this Kubernetes operator and this image. Is basically based on how strong hardware you have, and that pretty much defines how much stuff you can run in there. It also depends for what you are using your database, simple or in transaction database application. So
this approach assumes that you use bare metal configuration. You do not use like RDS service.
It basically don't assume that. It's just up to you for what you want to use it. I think the configuration would work the same. It's just if you want a stronger capacity that AWS cannot provide with their server, or they are too much expensive for your case, you can put 10 of your bare metal servers. Everything should work, or it work the same way.
Funny thing, on the first meetup we had here, we had 2 of 3 speakers that told us, don't do that. If you want performance, run bare metal. But I agree, we live in real world and we do something similar with Nomad and Postgres. So my question would be, do you have any recommendation for the tools, like for the pgtune or like configuration example that would optimize Postgres with the storage? I mean, some costs, some memory configuration, etc. And another thing, did you have any production experience with data loss, and how, if yes, what caused that and how did you fight that?
Okay, the first question was, don't do it. and it was, do I have some recommendation for tools for tuning Postgres that are running inside of Kubernetes? And the second was about, did I have some data loss? So for the first one, not any other tools that common one. That, I mean, it's basically is the same. I mean, there are pros and cons definitely of running Postgres in Kubernetes. If you want a lot of services quickly for testing and for developing, then perhaps it's the way to go. If you want something that needs high power, a lot of calculations inside the database, and if you need small amount of them, then it's just the overkill to run it in Kubernetes. This just basically show how it could be done if one company needs a lot of data. If you want to provide database that are high available quickly, with all the things that can happen behind if something goes wrong. It's up to everyone to choose, is it worth trying? Do you need it or not? It's just about use case. And do I have experience of data loss? Before Cybertech, I ran inside of Kubernetes Postgres. I must admit there's not a lot of them, and they are used not that heavily, but I would say they are in production and running well, and no data loss there. So in my experience, no.
Especially about Docker Postgres images, what you are using. You are download from Docker Hub custom official image, and then you install all these plugins, functions automated by Docker YAML file, or you are pre-cooked your database and then containerize.
Okay, so the question was, do I use Postgres official image or do I pre-cook the Postgres for using inside of Kubernetes? So I mentioned there is image called Spilo, and that is predefined Postgres image with the stuff, the only stuff that we need for Postgres in Kubernetes. So they are just binaries. They are just extension modules file, SO files, and some additional tools. So that image basically weighs a little above 100 megabytes. It's already prepared for production, and it's light. So it is definitely custom image. Now, if you want to customize it, like to add some other extension that is not in contrib, or to remove something, I think that's the good starting point to pre-cook that one instead of Postgres or official Docker image.
Can you name it one more time?
Spilo.
Okay, thank you.
There's one more.
So you mentioned that Spilo. So you mentioned that Spilo uses Python daemon that restart the Postgres inside the image.
Yeah.
And then the question is, in case you are using stateful set, why do you need this Python daemon when Kubernetes will restart the container when it dies?
So the question was, do I use Python daemon inside of Spilo image to take care of the Postgres HA when I can use Kubernetes?
Like Kubernetes does it by default. So.
Yeah. So the Python binary is actually Patroni. That is tool for monitoring cluster and keep them in healthy state. And there is a lot of functionality that are already prepared for Postgres streaming replication. So the main reason is actually that Patroni controls streaming replication that Kubernetes don't know how to do, right? And all that combined together actually does the HA of Postgres inside of Kubernetes.
And the next, like the other question, why not just use daemon sets and not stateful sets? So we ensure that per each node we run one replica of this Spilo image.
Why not? Because with stateful set you need always the same name. So in case of one of those Postgres installation dies, right? The Postgres operator needs to mark it as down, and when restarting it, it needs to have the same name, right?
Oh, okay.